In the following tutorial we will be using a Prosig P8000, Prosig DATS analysis software and Thermocouples. To begin, I will load the DATS analysis software. And when the DATS analysis software loads, it will present me with a dialog box to inform me that I'm currently using the standard analysis interface and I can change to the advanced mode if I would like to. I'm going to select the DATS acquisition software . And we can see in this particular situation I have a 16 channel P8020 with 8 thermocouple channels and 2 tachometer channels. And for the purposes of this tutorial I'm going to be solely using one of the thermocouple channels. So to begin, I need to set up my signal setup matrix to suit my requirements. So I will be using the first thermocouple channel and I will give it a name, thermocouple example. I need to choose a auxiliary sample rate for the thermocouple channels and I'm going to select 50 samples per second per channel. I'm going to store a data capture for 10 seconds and I need to choose where I'm going to save my target data file. And for this I'm going to create a new folder on my desktop . In a folder I'll call Thermocouple, and the data I will call data-001. It's important to end the file name with a number, as the software can automatically increment the numerical file name for you after each capture. I'm just going to apply these changes, and I have to set in the signal setup matrix the type of thermocouple that I'm using, and in this particular example I have a J-type thermocouple, so I just select the thermocouple type column, select my type of thermocouple, in my case J, and it would be a good idea for me to save my setup matrix for later use, so I'll do that as well. Just simply File, Save Setup As, in my thermocouple folder, and I'll call it Setup. So I'm now ready to arm this system, and I do that using the arm button. And we'll see in the bottom left hand corner of the screen that the P8000 is currently now armed, and we can see that we do indeed have a temperature reading on the thermocouple which I have plugged in. What I'd like to do before I do my data captures is just to set up some real-time displays. So a time series trace for the thermocouple, for example, and perhaps a digital panel for the thermocouple so we can read the instantaneous values. And I'm just going to adjust the settings to show a little bit less in terms of decimal places on the digital panel. And if I just put my fingers onto the thermocouple, currently we're looking at about 25 degrees, which is the ambient temperature of the room I'm in. If I put my fingers onto the thermocouple, we should see a little bit of a change. We can just try auto-scaling that graph just to see the differences. Just right click and select auto-scale, and we can see that my body heat does seem to be changing the temperature of the thermocouple quite a bit. And what I'm going to do is I have 2 glasses of water in front of me. One is warm and one is very, very hot. So I'm going to put the thermocouple onto the hot glass of water first of all, and you'll see the temperature start to rise. And we'll leave that for a few seconds just to see how fast and how high the temperature is of that first glass. and that seems to have stabilised at around 45 degrees. I'm now going to put the thermocouple onto the colder of the two glasses, and we see the temperature drop. The ambient was about 25 before, and the temperature is continuing to drop. 21, 20, now down into the teens. So it looks like my glass of water, the cold one, is about 19 degrees and the warm one is about 45 degrees. So I'm going to let the thermocouple just go back to ambient temperature now, and I'm going to begin the data capture, which will only last for 5 seconds. So I'll move between the warm glass and the cold glass very, very quickly. So I'm just going to begin my data capture by clicking on the record button. So we'll start at ambient temperature. I'll go straight onto the cold glass, and we can see the temperature drop down, and about 50% I'll go for the warm glass, and we can see the temperature start to come up again, and our capture is complete, and the system has automatically disarmed, and the system is now ready to capture data again in file 002. And I think I'd like to capture data for a little bit longer, so I'm going to select 30 seconds, and now my second data capture will be for 30 seconds. So I'll just rearm the system, and again we're about ambient temperature. I'm just going to click on the record button, and I'll put the thermocouple onto the cold glass, and what we should see is the temperature start to come down to about 19. And then what I'm going to do, it looks like it's stabilised about 20. What I'm going to do is just put the thermocouple onto the very warm glass, and we should see the temperature come up to about 45, just as our data capture is coming to an end. So we've now captured 2 data files using the thermocouple, and if we'd like to analyse those data files, we can just exit from the DATS data acquisition software. It's always a good idea for us to save our changes. So our setup file, and we can now examine the data which we've captured. And we can see clearly here we have the first data set for 10 seconds, the second data set which lasts for 30 seconds, and we can see the temperature changes over time. Simply clicking on the cursor button will give us the cursor values and allow us to read the values off at certain times of the data, and we can then go on and perform any sort of analysis that we can with the DATS analysis software. This concludes our tutorial on using thermocouples.